A particle of mass 5 is moving with a uniform speed v equal to 3 root 2 in the XOY plane along the line y equal to x plus 4. The magnitude of the angular momentum of the particle about the origin is how much? In this problem, the particle is moving in the XY plane, that is in the plane of the paper. The angular momentum is along the line perpendicular to the plane of the paper, and it is given that the mass of the particle is 5 and it is moving with a uniform speed v equal to 3 root 2, which is uniform in the XOY plane, and the particle is moving in the XY plane and along the line y equal to x plus 4. Suppose the particle is here at this point, the momentum of the particle is mv. When the particle is here, suppose this is the origin and this is your x-axis and this is your y-axis. So when given y equal to x plus 4, so when x equal to 0, here x equal to 0, y will be equal to 4. That means this distance is the radius. This is the radius of the circular path. So r will be equal to 4. When v equal to uniform, the angular momentum is given by mv r sin theta. Either you write mr v sin theta or mv r sin theta. Angular momentum can be changed by varying r or by varying v. Since here v is uniform and mass is given, the equation is given y equal to x plus 4, and we know the equation of a straight line y is equal to mx plus c, and here y equal to x plus 4. So slope, m is the slope, that is equal to tan theta. Tan theta is equal to 1, so theta will be equal to 45 degree. So the angular momentum will be equal to m, that is 5, v given 3 root 2, and r we have found out 4, and sine 45 degree is 1 by root 2. So if you solve it, this will be equal to 60 units. So the angular momentum of the particle will be 60 units. And this is the magnitude of the angular momentum of the particle about the origin. And the direction of the angular momentum is along the line perpendicular to the XY plane, that means along this direction.